Hello, everyone. Today is May 15th, 2025. This is the Kubernetes storage SIG meeting. So today we will start with 1.34 planning. So there is a PR out for 1.34 release cycle. This PR is not merged yet. I just copied this. This is a tentative schedule. So PRR readiness PRR freezes on June 12th, and enhancement freeze is on June 19th. And August 27th is the GA date. So let me go to this planning spreadsheet. So here I copied 1.33 spreadsheet to 1.34. If you have any other items that you want to target for 1.34, please add it at the end of this. I think you should be able to add a comment, or you can pin one of the leads to add it here. So let me just go over this. So the first one is recovering from resize failure. This moving to beta in 1.33. So this is done. Do you have anything that we want to target in 1.34? Is Hemant here?
I think Hemant wanted the resize fair.
So do we want to
do we GA?
This? Or we can just we can leave this like this and we can check it.
I think we can uncross it.
Oh, okay.
And go to GA. Try to go to GA.
Okay. Just to GA. So just change this to. Thank you.
And the target status and the column E and F.
E and F. Oh yes. Thank you. Okay. And then this is G. Yeah. Okay. Thank you for that.
Thank you.
Okay. So that's this one. So next one, working group snapshot. So we are going to do V1 beta 2. So we have a cap PR update ready. So stay in beta. Say. Oh, okay, so this one should be beta as well. And then the next one is CSI volume health. So I think this is we started to have some discussions, and we are working on a doc. Is Sunny? There is someone in your team that is putting together some doc, right?
Yeah, so we are just trying to collect use case right now.
Okay. So I'll just leave it like this. Yeah, still not sure. And then the next one, change block tracking. So this one moved to alpha in 1.33. So I think we're going to stay in alpha. I don't know if we still need to track this. For now, I think we can just cross this out. Ben, do you think so? We will continue to follow up in the data protection working group, but I don't know if there's anything we need to follow up here.
Yeah, I mean, I think the update is status quo.
Okay, let me just cross this out for now. Let's say alpha. Oops. Oh. Okay, so just say starting, let's start it alpha. Yeah, this is and then next one is enable privileged containers Windows to replace CSI proxy for Windows. Somebody is talking. If you're not talking, please mute. Okay. So I think there is an update from Mauricio. Is Mauricio on the call? He added some notes here. So maybe he's not on the call. So this is his notes. Yeah, so we do have so vSphere CSI driver also started to use CSI proxy v2. So there are two drivers. Are we good to move it to GA now? So it looks like that's the plan. So we can say target GA.
So CSI proxy v2 is going GA in 1.34.
Oh, is this actually, I'm a little confused. I thought it says moving to beta. Is it beta or GA? So I'm, is someone here knows this, or Eddie or someone? Because it says, if I look at this one, right, this is the last notes from last time. It says interested in moving to beta. Is it beta or GA? Now I'm confused. Now it's ready to move from alpha. Oh, okay, alpha to beta. Okay, maybe beta first. GA is the okay. That's probably what it means. Yeah, I was confused to see what's the status. Yeah, this because here we are saying alpha to beta, right? Okay, does anyone have any updates, or just say we will target beta? So yeah, Mauricio is working on cap update. And then next one is Linux labeling using mount options. So okay, so Yang, so we moved to beta last time.
Yes, we just moved to beta, so it will stay as beta.
Okay, so we don't need to do anything for this one for now, right?
Yep.
We should change this one, say beta. Yeah, okay, I'll just cross this one out for now. We can move this and then we can bring this back when we want to move the status again. Okay. Then the next one is voting attributes. Do we have another one for skilling? So this, oh, okay, that's down here. Skilling labeling is one option. This is a rewrite one's pod. Do we need to do anything for this one?
No,
Okay.
all of them will graduate.
Okay, the same time. So basically now both are beta, right? Okay.
Yes.
So just let me just add a note. So transfers. So both. C2. And the next one is voting attributes class.
Yeah, so we are planning to go GA in 1.34.
Okay. The quota, is this merged, the quota thing?
Yes, it's merged.
Okay. GA. Next one is CSS sidecar all in one. Do we have any update on this one? So notes from last time say move to 1.34. So I think we just keep it. It's actually no update, but probably the same. We'll just move it to 1.34. So keep this one like this. Next one is, what is this one? Remove and provision support from host path entry. So I think this one was added by Corey some time ago, but I think we need to wait for Portworx. Now Portworx is GA. I don't know if this is ready. So he can bring we can come back to this one if you want to work on this and say check. So I'm not sure yet. Next one is okay. So the Git repo. This is done. This too. I think we are. Oh, actually, let's see. I think we have some. I think we need to. So the first one is done, right? This is done. Now this feature moved to alpha. So I don't know if there's any plan to change the status. Sad, do you know if there's anything? Are we doing anything for Git repo? Again, there's this feature.
I think the remaining work was removing the code.
I think
So I think that
kind of us, we still have to wait for quite some time. So
that's true. I guess once the feature flag is introduced, we'll have to wait.
Right.
So maybe let's just cross it out and then we can
Okay.
follow up on this in the next release.
Okay. Do we still need to keep this separate? Maybe the first one we don't need to keep two now.
Yeah, we can remove 11. Yeah.
Okay. Right. So next one is a mutable CSI node allocatable property. So this just move to alpha. Seeing Eddie here, so I'm not sure if okay, so I'll change this to alpha. Don't know if we're doing anything about this one. So maybe I'll cross this out for now. If Eddie want to do this, we can bring this down. Next one, cozy over mode to alpha 2. I think this is still ongoing. So just yeah, still the same. So continue. 134. And the next one, storage capacity scoring. So this is just multi alpha. So I don't know if we are doing anything else. Probably need to wait a little bit before we move to the next stage. So let me cross this out for now, unless someone want to speak up about this. And next one is one expansion for stateful set, targeting 1.34. So are we doing this work in 1.34? Seeing the author here, so I'll just check with the head author. Next one is voting populator. Sunny, are we doing anything? Oh, this one is already GA, so are we done?
Yeah, and the blog post is post.
Oh, okay.
Oh,
So we can remove this, right? We don't need to track this anymore. Do we still need to track it here?
No, I don't think so.
Next one, CSI migration portworx. So this is GA, so we are done. Yeah, do you think we still need to keep this here? I think we can just
Do we need to track the feature gate removal?
okay, well, let's keep it then. Keep it.
Is there anything special that needs to be done for the feature gate removal? Or is it just like any
just
other?
remove it. Just basically we just need to remove that entry, right?
We usually also remove the entry plugin when we remove the feature gate.
Oh, okay. So okay, removal of the code. That's true. Okay, so let's keep it. Keep this to track.
But it will be removed in, I don't know, 135,
I think it's not, yeah.
6
I think later we'll have that. I think it's like 3 releases.
at least.
Okay. And did we have a release note about the Portworx migration GA?
Yeah, that's actually a good point. So we need to check. Need to check.
Because people need to start potentially. Oh wait, actually, well, with CSI migration, they shouldn't need to do anything. Well, I guess they need to start running the CSI driver.
Yeah.
So there is some action required.
I think that it should have something, but I didn't double check. I don't know. Okay, you check if everything else have this too. There should be some like action required, things like that. Okay, the track entry plugin removal and also the feature gate removal. So we probably actually should keep the the volume populated one for a little bit longer, yeah, because sometimes we forgot to remove we probably should keep all of those here a little bit longer. Okay, so let's keep it here for that. I'll just check the release notes. And always honor return policy. So this one is the same. It's GA. So let's just keep this one here, just to track, the feature gate. GA. Let's see. Keep, just to track the feature gate. And then next one, integrate CSI volume limits with autoscaler.
So,
Oh,
yeah, I opened enhancement in the clusters autoscaler repository.
oh, okay.
So they have a different process for tracking. I do have enhancement in main this thing like a issue, but I don't know if we need a cap for this actually in
Oh, they don't
enhancement.
do cap because it's a kind of auto tree thing. Is that
Yeah, the cluster autoscaler is out of tree, not a part of Kubernetes.
so?
Kubernetes. It does require a change in Kubernetes repository also, but that change has to come later. So
Okay.
I still will open issue and enhancement probably, but most of the work is being discussed in the autoscaler
Well, you have
repository.
I think it's still good to just have a KEP anyway, since that's where we put like all of our design documents usually. So it's just nice to have it in one place. We don't have to like follow the deadlines and stuff, but I think it's just easier, right, if we have all our designs in one place in general.
Yeah, I agree. Yes, sorry. Xing, you were saying like you have a link. I'll link the.
okay. Yeah, I think it's a good. Yeah, I think that's actually good. We should have that since we even know what this work means. Okay. All right. And
This will be like, yeah, alpha we are targeting for this.
oh, alpha, okay. So what would be the priority? The 3?
Two or three, yeah.
Okay, just make this 3. Okay. And next one is this kubelet inventive design state or the populator. This, there is a cap out there, right? Okay, so move to 1.34. Is this the plan?
I saw that the author has updated their design and everything, so we need to review it again. I haven't because the original design was not workable, but I haven't had chance to review it, and I think they are targeting 134.
Okay, all right. So I added to this replication relationship. This is something we started to discuss in the data protection group. So Ben, so I added you as the reviewer. Okay, so and next one, reduce attached latency.
Yeah, I just added this one.
Oh, okay.
But yeah, we discussed this a couple weeks ago, I think, but we're basically doing some prototyping to figure out how to reduce attached latency. And so far, we found that the bulk of the bottleneck is spent in kubelet, waiting for kubelet to update the volumes in use field.
Oh.
And so we're talking with Node folks to figure out if there's a way we can kind of decouple the volumes in use update from the rest of the node status update flow, so that we can kind of make it more event-based rather than a 10-second periodic pull.
Thank you.
That actually sounds really cool. I like that idea.
But yeah, so we're actively discussing with some SIG node folks about this and exploring some ideas. I'm not sure if we'll make the CAP deadline. When is that again?
Let's see. I think it's pretty soon. They have something. Yeah, it's June. It's like a month, literally.
Oh, a month?
Yeah, June 19th.
Okay, we might be able to do something by then.
Oh, okay.
Like
Cool.
right now we're just doing a lot of prototyping right now.
I see. Okay.
So yeah, we might be able to make it.
Okay. Great then. So you want to change this to alpha?
Yeah, we can do that.
Yeah, try that, right? Okay.
Yeah.
Great. Okay, so if there are anything else, anyone want to target in 1.34, please add an item here or just let one of the leads know and get it added. Okay, so now going back to the agenda doc, we have so we have something here, node readiness gates. Jay, you want to talk about this? Do you want to share anything? I can make you a
Yeah, could you please like give me share permissions today?
Co-host. Okay, yes. So I will stop share and please share.
Is my screen visible?
Yeah,
Can you
yes,
focus on
you
my
can
screen?
see.
Okay.
Yes.
All right. So I'm here today to propose some idea. I'm working on the node area. Had this proposal in SIG node, which has been accepted for provisionally for design. And initially we want to target the problems in the Kubernetes areas, which are like very close, like core to the signaling, basically like network readiness and storage readiness. I wanted to share this idea with SIG storage today and gather feedbacks and see how the interest and the problems fit in here today. I'll start with the problem first. So kubelet today has one ready signal, and kubelet says ready, sets ready as true. What does it mean? It doesn't necessarily mean that the node is fully equipped to run the complex application workloads today. So this ready condition is basic, and it's often insufficient. In the case of storage, that could be like storage layering or like volume, like setup that may need to come before, for example, the application owner can run databases on top. Provisioning pods before this ready signal comes often end up in pod failures or tricky state where, for example, one of the use cases I have seen today was the autoscaler seeing volume was infinity, right? So that was one of the issues that was common pattern often seen even across like network readiness, where the CNI is not ready, but the pod gets provisioned, and then a secondary CNI is installed. So that's like a generic problem across different Kubernetes articles. So this pain point is what I intend to address, what we intend to address in SIG node. So the goal is to have more declarative readiness signals from the node itself. Node says when it is ready. So that's the idea. So how is it achieved? So there are two aspects here. First is node having a standardized way to express its readiness, having more granular readiness levels than just a singular ready condition. The second aspect is having a way for Kubernetes users to gate the pods until certain requirements is met. In this proposal today, what we are targeting is like until all of the node readiness conditions are met. So the spec would look like this. It would have like an array of readiness gates that scheduler will abide by before assigning pods or workloads on the node. I quickly share the API layer to capture this idea better. So this is proposed today as a kubelet level configuration. So when the node bootstraps, it would find what are all the conditions the node expects to be met before it can accept workloads. So it is, one example here is like the CNI ready condition. Another I have presented here is like a CSI plugin, whether it is ready. I would go into the details on the configurations after, but these are the two readiness gates. The node says I need to be satisfied before I can be assigned the pods. So the scheduler will have like a plugin that would expect to see these conditions in the node's condition. This is status.conditions is the observed state of the node. It would expect to have, in this case, network kubernetes.io CNI Cilium ready, status true, and storage kubernetes.io CSI, like csexample.com. Like these two conditions to be satisfied as true. These two conditions are present in the node spec. So it will retrieve these ideas. Like scheduler will get the nodes spec from the API server, and then as soon as like kubelet has an update on the, sorry, let me correct that. Node object has an update on the status conditions. This scheduler will have an updated view of the node, and then during the pod scheduling stage, it would ensure that the node is eligible to run the pods, and then would assign the pods on the node. that's how I intend to like target this. Now there are like two critical problems we want to talk. So this is declarative. That would mean that like the user says, okay, I expect this condition like CSI plugin to be ready on this node before workloads are assigned on the node. So who satisfies the condition? So since this is external component managed, the third-party component managed, the condition in itself, we propose that would be managed by the condition. This is more simplistic on the kubelet in itself. The kubelet core would process the initial bootstrap configuration and it would populate that on the initial node spec. That's like the current goal for kubelet. And currently there is no health, as I understand correctly, there is no health export from the CSA plugin, or there is no correct way to say, hey, I'm ready. That's what I want to discuss today and like make sure how this can this is handled today in plugins, or how this can in turn work. But
so
the idea is
if we had the health signal, sorry to interrupt. I just, you can have multiple CSI plugins per node, and so like, does this proposal handle like if you have 3 CSI plugins and 2 are ready and 1 isn't? Like, what do you do?
Right. So that right now, what we are saying here is like the spec carries what is expected on the node. So if the user decides, I just want the NFS plugin to be ready and mentions that on the spec, that's the scheduler would expect. The NFS need to be satisfied before the parts are assigned. If there is like a secondary plugin that's installed, maybe as a, CSP installs this later, but that is not in the initial spec, the CSI or the CSI installation can also do a patch on the node spec. So scheduler would, from that point onward, would expect that condition to be met. But
so some human has to say like which CSI plugins you care about for the purpose of scheduling.
Right. It's up to a controller or a human, whoever node admin has to manage that, because there's a node readiness signal on what's assigned on the node. Yeah.
And is there an expectation that like if you are performing a software upgrade and the CSI driver that was previously healthy becomes unhealthy, or you basically kill it to do a software upgrade, that that would be reflected?
That's a great question. Now, this again comes in 2 aspects. Now, if the agent or the plugin in itself exports its health signal, I'm imagining something like a sidecar that just like looks up a health C endpoint, then that would automatically patch the condition to be initializing and set the status as false. And once the update is finished, it would lift the scheduling gate. Now, this has problems.
So something is constantly polling for health, and the moment it goes unhealthy, the node is updated to reflect that.
Something that's constantly monitoring the health on the node. Yes, that's up to the implementation, I would say. If this is more like just an initial layering, it can just be like a one-time thing, like a script that just like patches this condition. So every time when, for example, node reboots, the pod will be layered on the node again, and it will make sure that the installation is finished until update. It doesn't need to be constant monitoring, but if that's necessary, I think that like can be achieved. But the idea is that like it's enabling a generic framework, a way for holding the node for certain readiness on the readiness condition on the node.
Well, but if the node was healthy and then it rebooted, and the CSI plugin is going to take a while to get ready again, like what transitions it from true to false?
Right. So I see that like when a node reboots, the pod will be reinitialized. Now the condition mismatches on the node object. The API server object would still see the old condition. Condition is true. I think that like there should be like a standardized pattern that could solve this, because like Kubernetes cannot reset a condition that is set on a purpose on a condition. So the agent should start with initializing or an upgrade, and then once it's complete, it would set the readiness condition as true. That's how it could be handled for a pod level restart, for just kind of an upgrade component, or like a node level restart. And this would also mean that like when kubelet accidentally restarts, or and the plugin is still available and running, it shouldn't disturb the component readiness conditions. It also inherently handles that.
Yeah, I'm just thinking that whatever is responsible for updating the status, if that thing is itself slow, you'll still have windows of time where you have stale status and it's inaccurate. And then what has it bought you, right? Because the assumption is it was going to get ready eventually, and this just sort of lets you hold off on scheduling until that time. But if it can be wrong and it can say, yeah, I'm ready, but the monitoring component just hasn't started yet, then you'll schedule pods and they'll be waiting, which is the situation you wanted to avoid.
So I think that like we are looking at like a problem that can happen when there is like a controller that's outside of the node, or when something that's faulty that on the agent that's maybe exposing, right, the signal. I think that like if this is like goes in unison, like on a pod that's like a sidecar, I think that is less likely to happen, I would assume. And there is one scenario you clearly pointed out. What if it locks out the node from layering the node? That's why I think like let me go into the configuration more. The idea is to have like a timeout on the specific gate, and the kubelet will look for like a certain gate to be ready or not within that timeout. If it doesn't, it would perform the failure action as described by the gate. Example in this here would be to like taint the node. So it would set the specified readiness taint, like for example, set the plugin as not ready, and the effect could be either no schedule or like it's like a standard Kubernetes pattern of setting this up, like need for maintenance. So this would call for the systems that would address replacing the node or like patching the agent upgrade on that specific node.
Yeah, I guess I'm unsure of what this is really gonna, like what improvement we're gonna get at the end of all this.
So my goal is that like if a node is not ready, like assuming that like a installation failure or it's like a mismatch on the version or anything that doesn't allow like a pod that is intended to run on the node, right? Like if that pod lands on the node, it doesn't achieve the desired goal. Like
So you're more worried about permanent failures than like if it takes a minute for the thing to start up, you want to wait to schedule any pods for that 1 minute. You're worried about the node is never going to be healthy, and you just want to steer the scheduler away from it.
Right.
So from like Stuart's perspective, what this solves is like we have seen with EBS and other drivers, like when a new node comes and its CSI driver is not installed yet, so it's not reporting any limit in the beginning because there's no CSI driver installed it, and then you have like 30 or 40 pods ready to be waiting to be scheduled. So the scheduler will send all 40 parts on the same node that were just spun. It happens, and then a bunch of those 10 of those parts will be permanently stuck in container creating, and it requires admin change, admin manual intervention to solve this problem, to get those parts to schedule somewhere else. So
okay, that's good background. So if you're in like a resource constrained situation where you have more pods than nodes to run them on, and a new node is up, you see a flood of activity.
Yeah, so this will solve with that problem. It will also solve with the cluster autoscaler limit change that I'm working on, where like when I'm trying to integrate CSI node limit into cluster autoscaler, we have to consider like when a node is ready and have the CSI driver installed, because we don't want to keep spinning new nodes if the existing, if while the node is not reporting any CSI limit, right? So we have to wait for that node and the CSI driver to be installed so that we can consider it for scheduling. So this proposal helps with that too, actually. So yeah.
Martin, your first example, why do they get stuck? Why do they require human intervention to fix?
So because the pod is already scheduled to the node, like the node supports, let's say, only 10 volumes that can be attached to the node.
I see.
And we sent like 30 pods with each one. Then 20 pods you have to. They will be stuck in container creating state, not pending scheduling. Pending is good, then they can schedule somewhere else, but they will be stuck in container creating, which is bad.
So is the result that when the node is running but the CSI driver isn't ready yet, you like taint it somehow? Like, what is the actual mechanism to stop the scheduler from picking that node until you can?
Right now in the core Kubernetes, there's none. It's a bug that exists.
No, you're right. I'm saying in this proposal, what would the mechanism be to actually stop the scheduler from doing?
So in this
drives?
proposal, and I have some questions that I'll get to, but in this proposal, let's say when the node object is created, it has a spec that says that readiness gate that it says that storage.kubernetes like EBS it should report as ready actually. So the kubelet object, the kubelet, when it looks at the node and it sees that okay, the CSI driver, that the condition is not reporting ready yet, the node will, as I understand it, node will be considered not ready because this condition is not satisfied for the scheduler at least. And when
so it'll reuse the existing taint, the not ready taints. That it'll just leave the taint on longer.
Yeah, I think so. I'm not fully sure about this tainting mechanism. Like, Ajay, can you like?
Yeah,
so,
I can answer that question.
Yeah.
So typically taint means like a differently, and taint is overloaded, like requiring maintenance. It's not the same as like the prerequisites are met. So first is like the semantics difference, and the second core problem is that like now you overload a taint without like a hierarchy or like without like a scope or like a wider. So what does no taint mean? No schedulable taint for what? Like, is it just for storage pods, or is it just like in the future, like having like an explicit readiness condition on the node enables you to have like a layered readiness on the scheduler side. So this opens up.
I'm just saying that there's already a not ready taint that's used for like when the node is not ready.
Right.
And that's what
I want to have a clear difference between that. Sorry to like go over there, but this doesn't change the existing ready equal to true. So now we have to also think about like a case where like there is infrastructure level readiness and then CSP operators are like further layering on top, like some service mesh provider or something like that. So the SLOs also need to be different. So ready equal to true, where the kubelets inherently means that like I'm up and running and ready to accept. That still says this is extensible or like additional readiness, more granular status on top of the ready. The not ready equal to true currently signals that the kubelet is ready or not. It's a Kubernetes or kubelet signal.
So
now how this is overcome by like, for example, like cluster autoscaler or like Cilium, they provide their own prefixed taint and try to standardize that. There is no like.
That's what I was thinking. I like putting a taint on new nodes and then removing it after the CSI driver is done initializing seems like the right way to do this. And I guess I'm failing to understand why this requires any change in the core of Kubernetes. Like, why couldn't the CSI driver just have a controller that taints nodes and removes them once the nodes are healthy?
So already bunch of drivers actually do that. The problem is, as I understand it, like then every that's not strictly backward compatible. Then you have like CSI driver installation itself. Those parts have to tolerate the taint or whatever that needs to be scheduled on the node to get the node going has to tolerate. So if node has to tolerate the taint, so so those parts have to be modified to tolerate the taint until the CSI driver comes and removes the taint. So that's an issue, and that's the first issue. Second issue is that the current mechanism of in Kubernetes scheduler, which sends the pods to a node that doesn't have CSI driver installed, we will not be able to get rid of that if we rely on the taint mechanism. We'll have to still send pods to node that doesn't have CSI driver installed in that case, because so that cluster autoscaler or whatever can consider schedule pods to that node. So those are
there's something I don't understand. Maybe you're more familiar with this. There's a CSI node object that gets created and that tells tells Kubernetes like which CSI drivers have been installed on the node, I think.
Yeah.
Could it be that as the new node is getting installed and the CSI driver isn't quite there yet? Like, do you know what the sequencing of do you know when the CSI node object actually says, yeah, I have the CSI driver? And can we rely on the existence or non-existence of that annotation?
CSI node objects, the bare bones object is created before Kubernetes, before kubelet reports are ready, but it's empty. It's not reporting any.
Right. That's what I mean. So it's there, and the CSI driver isn't there. So the scheduler could be taught that, like, hey, this pod needs an EBS volume. I see that the node doesn't have the EBS volume driver on it. Therefore, I'm not going to schedule it until the EBS volume shows up there. Like, because it would have to do that to do the limit check, wouldn't it? It would have to know what the limit is. So could it be taught to say, well, the thing isn't there yet, so the limit isn't set yet, so I shouldn't do anything?
Yeah. But that breaks cluster autoscaler. That breaks cluster autoscaler because cluster autoscaler imports the code of scheduler, and when it creates a new node to schedule all the pending part, then it gets a node object and it gets a CSI node object or whatever, but it doesn't know anything right now about it. So, but it has imported the scheduler code from core Kubernetes, and it looks at the pod and it looks at the node object, and the scheduler tells it that, oh, this cannot be scheduled on the node because, like CSI node object is not reporting the limit yet. So
yeah.
So the nascent is like an object that has not been fully realized, the node object. It must consider that object, that node object, to decide if this node will satisfy the conditions of the pod, because the cluster autoscaler imports the scheduler code. So that's the reason why we cannot blanket.
Are you saying the autoscaler will create node objects for nodes before they exist, and then something will conditionally make a real node that matches? That's really weird.
So they kind of simulate the node behavior and the scheduling behavior. That also has like sorry to interrupt you if you were to say add anything more, Hemant. Just wanted to make this point that that also has like a problem with not having standardized taints or specifically like a semantic difference for the initialization hold, which is what you're targeting with readiness gates. Of course, right now cluster autoscaler expects that okay, you have some taint and you want me to ignore that during my simulation. You have to add this prefix like ignore taint and then add your taint. That kind of makes looks like a hack, and it has been like a pain point, especially when you have to layer multiple CNIs that has certain hold conditions and readiness conditions that a layer up after. So that's the kind of a problems when we overload something that's not intended for the purpose.
So Ajay, I have a couple of questions actually. Originally, when I looked at this proposal last week, or I don't know when, you didn't have this readiness taint actually in the proposal. Is this new?
Yeah. Yes. This was addressed on the concern that what if like previously pointed out, what if the reporter is it's not functioning, or is it a failure, right? Then it's right to handle that in a Kubernetes way to mark this node as needing maintenance. So having a timeout and addressing that as a failure action as intended by the user would be the right way to go about it. They either can choose to taint it. Right now we are just looking at two types of policies for handling the timeouts. One is with a taint. There could be some taint management controllers that would really can see, okay, this is because the node is not ready, or because of the component upgrade is failing and it could stop the upgrade, specifically on how the use cases are or it could just bypass with a warning. I'm just imagining that if this is not going to be some drastic change that would be implemented on a large-scale providers, right? So just the scheduler gate can be disabled, or it can just be bypassed with warning. This kind of recovery action should be in place. So that's why the timeout actions, I think, is needed.
So this whole set of readiness gates sounds very complicated to me, and I admit I've only been thinking about it for like 10 minutes. But did you consider other approaches to the specific problem you mentioned, like some sort of pod eviction thing, that if there's too many pods that want to volumes that it can exceed some limit, you just evict the pods and then let them get recreated? So that in the scenario you described where new node pops up, every pod schedules to it because there's no limit yet. You could come in after the fact and clean it up, and then the right thing happens. Is there a reason that kind of approach can't work?
I'm not sure like if you're asking specifically the Heyman's problem to Heyman, but I could try to answer from a generic point of view. Would existing mechanisms can somehow be like the tools could be used to make like a problem work? But I think yes, that you could use metadata like labels and annotations and hand like specific code outside. The idea is to have like a more standardized like a generic framework to handle that. There is precedent in Kubernetes for readiness gates, for example, like
the generic framework I'm thinking about is something that enforces limits after the fact. So if limits are only enforced at scheduling time, you could also have something that says, okay, we're going to go kill pods that have been scheduled that would exceed the limit on the node. So that in a scenario where the limit didn't get set correctly and too many pods got scheduled, it just cleans it up, right? And then you don't need a human anymore. Then presumably whatever created those pods in the first place will create new pods that'll go back into pending, and you'll be done. I just like that kind of solution feels more like eventually consistent. It feels more Kubernetes friendly than like an elaborate system of, figuring out when everything is ready to go, right? Because Kubernetes, there's so many add-ons and so many daemon sets that can run on your nodes that can affect whether the node is in good shape or not. I don't know if we'll ever have a system that fully meets everyone's needs in terms of calculating, like, okay, the node, all of the things that have needed to happen have happened, and now let's start taking workloads.
So cluster descheduler they'll deal with something like unscheduling paths, but it has race conditions. It will race with scheduler, so that's why it cannot solve some of the issues. But as for like I'll say this the readiness thing is a real requirement even for like DRA and things like that. I don't know, Ajay, if you've been following, but the GPUs have similar problem. GPU drivers may not be ready by the time like like parts are ready to. I think you probably addressed it, but yes. So sorry, yeah. So
yeah, I was just
yeah. So the problem is real. It's and it affects all sort of systems, and having one design that address all of those will be useful.
Because so you're saying we're really trying to comprehensively address everything that can cause a node not to be ready by somehow pre-registering the list of things that matter in this cluster, and then having software that actually sets all the flags before the node gets marked ready.
I would say like that's per node, and I'm not saying this is like a silver bullet that solves everything. It's kind of like giving that infra admin, okay, I need to see this like a security layering that needs to be installed before like application owners can do certain things, or like this is like a storage provider who wants to have like the storage volumes or like the layers are set and ready on this node before like application owners can. Basically, it's giving that control on top of the existing mechanisms to the Kubernetes or infra user.
Cool.
Okay, I mean, it sounds like a really hard problem. I hope that if you're actually trying to solve that whole problem, that we're able to comprehensively solve it.
Right. My goal is to start small. Like right now, my intent is that like to get the standardized conditions like ready for what like the network and storage. Like network has been a problem for a long time, especially because when multiple CNIs are installed, the network, the pods that landed before like a secondary CNI installed, it's no longer reachable or addressable. So it kinds of like calls for many manual intervention. And I see that pattern as like even Heyman pointed out, like some of the problems that are also generic on like waiting for storage. My main goal is to establish that pattern of like expressing readiness, granular readiness signals on the node itself, allowing for a scheduler to have these visible fields on the node to act on it. Like this is kind of the filtering on the scheduler where when user expresses this certain readiness is present, then it expect to see that readiness conditions are satisfied before filtering the node. So these are the minimal aspects we are targeting. It's not generically open-net, but we are evolving for node to be more declarative in that direction.
Hey, I'm sorry, I think we are on the top of the hour. Do you have more slides? Or
I just have some quick, I think I got a lot of points here. Maybe I could further gather feedback or on the issue, or maybe with folks offline further or on the next meetings. I just have open conditions on the ready signal for storage plugins, but yeah, I'll pause on the document here. Please feel free to add comments or thoughts on that. Happy to discuss further. Maybe schedule some time next week if needed.
yeah, can you add this to the agenda doc? I think the one you added is a Google Doc, right? Was that an issue? It's an issue. Yeah, you can add your.
Right. I look at the emails.
Okay, yeah, that'll be good. Then people can review that and add comments, and you can come back in the next meeting to discuss more. You can also,
yeah, sure, that sounds good.
If you're going to submit a CAP, you can also review the CAP. Or is that your plan to eventually submit a CAP?
Yeah, the CAP is in progress. It's already proposed, and is provincially discussed and accepted at Node.
Okay.
I will capture the CAP details.
All right. Okay. Thank you. And then I see there are two. So there are two more items. Can we move that to next meeting, or is there anything urgent we need to have a quick discussion about those? There's one about the emulation version and the utils.
Yeah, my item is not urgent. It can be moved to the next meeting. Thank you.
This is the
Yes, the utils release.
Oh, util release.
Thank you.
All right. Yeah. Okay. What about the other one? Is it okay to move to next meeting about the emulation version? I didn't get that. Sorry, is the Siren still here? It looks like okay. I'll just add on and move to next meeting. Okay. Thank you.
Thank you for all the discussion.
Bye.
Thank you.